Good morning, students. Am I audible to all of you? Am I audible to all of you, students? Yes or no? Please, someone respond.
Sir.
Yes.
Yeah.
Okay. Uh, so let us start. Okay. So yesterday we studied regarding stress, strain, and Hooke's law, and different parts of the stress strain graph. Huh. So now today, what we will do is, can you see this? Can you see the presentation? Students, can you see the presentation?
Yes, sir.
Okay. So today we will be discussing about more in detail regarding stress and strain. Okay. First of all, this the first diagram. The first diagram is this. This diagram is a stress strain diagram for brittle material. What does brittle material means? A brittle material is a type of material that is easily breakable. That means it does not show any properties of elasticity. So here what happens is that this is a typical stress strain diagram for brittle iron, where brittle material, that means cast iron or maybe concrete. Okay, so here only there are two points. So number A is what? Proportional limit, and number B is what? Breaking point. That means what? If this is the stress in this direction and we have strain in this direction, so basically what happens, it increases in stress up to point A, it is directly proportional. Here up to this point, it's directly proportional. But beyond this point, if you keep on increasing the stress, then what happens? It shows some random behavior, and eventually, when it reaches at this point, that is point B, it undergoes failure. So this is what. Now there is one term called proof stress. You have to remember this term. Okay. Now for proof stress, that means what? When the stress corresponding to 0.2% strain is called proof stress. What does that basically means? So it means that when the stress value and strain value, if you compare the stress value and strain value, okay, if you compare the stress value and strain value, then 0.2%, 0.2% of the stress value. So suppose the stress is 400 Newton. So you all know how much will be strain. It will be 0.2%. Okay, if it is 0.2%, then that value is called proof stress. This is the term. Okay. Now, if you see the following diagram here, what you will get here is this is stress and this is strain. So now the strain corresponding to 0.2%, okay, is called proof stress of the material. Stress corresponding to 0.2% of strain is called proof stress of material. Remember this. This is how the graph will look. So this is how the graph will look. Okay, as shown in figure, this is how the graph will look for proof stress. Okay, so now after that we'll go for the different modulus. So first of all, we'll go for modulus of rigidity. Remember yesterday we discussed that stress is directly proportional to strain, right? Stress is directly proportional to strain. Then we have one ratio. That ratio is known as Young's modulus. If you can see this presentation, here we have this Young's modulus. You can write it as Young's modulus, M O D U L U S. So this is called Young's modulus. So first of all, let us know what is Young's modulus. Now we all know according to Hooke's law, what stress is directly proportional to strain, right? If stress is directly proportional to strain, then yesterday we got one constant, that is E. Okay, sigma is directly proportional to epsilon, and then we got another constant E. That constant is basically known as Young's modulus. Yesterday we discussed regarding that. Young's modulus is varying from different type of materials. Is it clear, everyone? Is it clear, everyone?
Sir.
So after that, we have modulus of rigidity. So if you see modulus of rigidity, modulus of rigidity, it means what? Shear stress is directly proportional to shear strain. Now, in previous classes, we discussed regarding this shear stress and shear strain. So for this case, you just basically know this this one like this, that the constant that arises when shear stress is directly proportional to shear strain, that is known as modulus of rigidity. Okay, so tau is shear stress and gamma is shear strain. Okay, these two are proportional to each other as per Hooke's law. Then it is defined as modulus of rigidity. Now these things we'll be revising in the next semester also. So you just understand the concepts right now. In detail, we'll be going in the next semesters. So later, next we come to hello, hello. Yeah, anyone is having any problem? Someone is speaking.
Sir.
Yeah, Mew. Say, yeah, Mew. I can't hear you. Can you please repeat what you have having problem?
No,
No.
no problem.
Okay. So after that, we are having lateral strain and Poisson's ratio. What does lateral strain and Poisson's ratio means? Any material that is subject to an axial strain that undergoes strains in its perpendicular directions also. So that ratio of lateral strain to longitudinal strain is defined as the ratio which is called Poisson's ratio. Suppose this is a suppose this is a material. So after that, the forces are applied here and here, because of which there will be a change in dimension in lateral direction also and in longitudinal direction also. So this change in dimension, that means strain that has occurred in both lateral and longitudinal directions, these are called, it is called as Poisson's ratio. Now the Poisson's ratio values, it varies in different materials. So for Poisson's ratio for normal material, it varies from 0.25 to 0.35, and the mathematically the maximum value of Poisson's ratio is 0.5. Now bulk modulus of elasticity. Now there is one term called bulk modulus. So what is actually bulk modulus? Suppose an object is having some some changes in its volume once the stress is applied. Then what happens? There is one change in ratio. Then it will get one ratio of strain, right? Volumetric strain, which is called as. That means what? There is one change in volume to original volume. Huh. So that ratio is actually known as what? volumetric strain. Now ratio of stress, that means the force that is being applied in that body, and to strain is known as bulk modulus. Okay, so here are certain relationships. These relationships are this in this semester. You can, if you want to remember, just remember. We'll solve numericals based on this in the upcoming classes, or upcoming in the higher semester. You'll be getting in more details. So now here are certain properties of materials that we will be discussing now. So here are certain properties of materials that we will be discussing now. Hello, students, can you hear me? Am I audible to all of you? I'm not getting any responses.
Yes, sir.
Hello,
Can hear.
hello,
Yes,
hello,
sir.
Hello.
Voice very, sir.
hello. I'm not able to hear any one of you. Hello,
Hello.
Voice, sir.
hello.
Hello.
Yes, sir.
It's okay now?
Voice very clearly, sir.
Clear now?
Yes, sir.
Okay. Okay, so let us do one thing. So let us, are your doubts regarding Poisson's ratio is cleared? Hello, students, is it clear for Poisson's ratio? Are your doubts regarding Poisson's ratio is clear? Hello, 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 hello.
Yes, sir. Yes, sir. You can continue.
Okay, just have a look at this video. You'll understand what is Poisson's ratio. Can you see the video? Hello.
Hello. Yes,
Yes.
sir.
Okay. So what is actually Poisson's ratio? If you see here, so look, there is one pull from both sides. So it is in longitudinal direction. Look, there is a change. Yes or no? So in lateral direction also there is one change. Now what happens? This is longitudinal strain. That means what? In the longitudinal direction, and and this is lateral, right? In lateral direction. Yes or no? Look, if you pull this from this both sides, okay, so what will happen? There will be one lateral strain, right? Lateral means what? If you can see the directions of the arrows in these directions and in this direction, there will be lateral strains. That means what? Here also the there is one change in length, that is delal, right? Now if you see here, what happens? In this part also the length increases. Yes or no? If you see the arrows, the green arrows here, this one and this one, right? So in this way what happens? This is how the lateral strain and longitudinal strain can be explained. So after that, this is actually what is known as the Poisson's ratio. That is mu. It is denoted by mu, and it is the ratio of lateral strain to longitudinal strain. I guess it is clear now, everyone. Hello.
Yes, sir.
It is clear now what is Poisson's ratio and how it is
It is
happening
clear
actually.
now what is Poisson's
Yes,
ratio and
sir.
how it is happening actually? Yes, sir. Yes, sir.
So I am trying to make it interesting for you people as much as I can. Just try to concentrate and ask me for your doubts. Right? So now this is what is for Poisson's ratio. Now if you see, there is another term called modulus of rigidity. That means what? Suppose if you apply certain amount of stress on a particular body, then what will happen? Eventually its volume will get decreased, right? So then this will known as modulus of rigidity or bulk modulus. Suppose I'm showing you a diagram now. Wait, give me a minute. Can you able to see this image? Are you able to see this image, students?
Yes, sir.
Yeah. So what happens? Just try to concentrate on it. Just try to concentrate on it. Suppose this is a solid object. Suppose this is a what? Solid solid body, okay? So now what happens? If you apply force or stress from all sides. So yesterday we discussed no P and F are almost equivalent. So if you apply the force from all the directions, what will happen? So these dotted lines, if you see certain dotted lines, so these dotted lines are what? These dotted lines are the original this, huh? This. So this dotted, now once stress is applied from all sides, then what happens? The volume gets reduced. This is the new volume. Yes or no? That means what? We all know the ratio of stress to strain. That means what? Here stress will be sigma. It will be denoted by P by A, but the strain, but the strain it will be what? It will be strain will be equal to what? Del V. Del V means what? What is del V actually? This is the origin. Suppose this is the volume V. Of this, this is having volume V. Now here it is reduced to certain amount. So the by amount which is reduced, that means similarly, we calculate del L, we'll be finding del V. So this is del V. That means the change in volume and divided by original volume. So bulk modulus or modulus of rigidity. What will be the formula of bulk modulus now? Can anyone say me? What will be the formula of bulk modulus?
E EB
Hmm?
EB by EA
E V
B
by
by EA
not EA. A del V.
del
Why? Because P by A divided by del V by V. Right? This is the formula for bulk modulus. So we can write this in this manner. Is it clear, everyone? Is it clear, everyone? Students, is it clear?
Yes sir.
Hello. Hello.
Yes, sir.
Yes sir.
Okay, fine. Okay, fine. So this is what is basically bulk modulus and Poisson's ratio. Okay. Bulk modulus, it is denoted by K. Bulk modulus or bulk modulus is denoted by K. And lateral Poisson's ratio is denoted by what? Mu. So this is what is the basic principles of bulk modulus and Poisson's ratio. Okay, answer, you had some doubts yesterday, you asked me. Are you there? Ansari? Ansari, are you there? Hello? He is there, but he is not
Yes
there,
sir.
I think so. Oh yeah, you're there now? So what doubt did you had yesterday?
regarding the stress strain curve,
Okay, so what kind of doubts you are having?
sir, from A to B, the proportionality limit will be changed or not, sir?
Right. So you are talking about this figure? Are you talking about this
Yes,
figure?
sir.
So, so what you
Yes, sir.
want? What you want from point A and point B?
From a proportionality limit. Yes, sir.
What proportionality limit will be changing? Which one? Which proportionality limit you are referring to?
From O to A, 0 to A, proportionality of stress is directly proportional to strain.
Yes.
So from A to B, will proportionality will change or remain
Yeah,
same,
obviously,
sir?
obviously, obviously. It will not be same. The part, look, though this is elastic part, hmm, though this is the elastic part, but only up to point A. Now, if you see the diagram, the elastic part is up to point B. The elastic part is up to point B, but the stress is directly proportional to strain only in this linear range. That means up from O to A only the stress is directly proportional to strain. Beyond this point, what happens? Beyond this point, if you see, the point B is known as elastic limit. This is not the proportional limit. That means up to point A only the graph is means it is proportional. Now from point A to B, the material behaves as an elastic material, but it will not be in proportional limit. That means the stress and strain will not be proportional to each other. Is it clear now? Hello, I'm sorry.
Yes,
Is it
sir.
clear? Any more doubts? Anyone? Anyone having any more doubts? No? Okay, fine. So what we are discussing now is material properties. So now in the material properties, that means what materials are having different properties. Okay. So under different loading conditions, the materials will behavior as different entities or different objects. Which means what? Suppose if so, we are having different applications of this material properties. Okay. Now, first of all, number one property is what? Strength. So, what is actually strength? Strength can be defined as the resistance, okay, that is offered by a material when subjected to some external load. So, the more stronger the material is, the more load it can withstand or it can resist. Suppose I'm giving an example of steel and plastic. What happens? In steel and plastic, huh? In steel and plastic, there is a difference in strength, right? So for a given amount of load, a plastic will break more easily than the amount of steel. Okay, that is known as the strength. Now the strength can be tensile, compressive, shear, or torsional. So you all know tensile and compressive. We discussed it before. Shear also you all know. Shear means what? Suppose the bottom portion is fixed. I showed you using a book. And, now that is known as the shear. What is torsional actually? Do you know what is torsion? Do you have any idea what is torsion?
No,
No? So what is actually torsion?
no.
Suppose when you wash your clothes, after that you rinse it, right? That means what? You after washing it, you allow the water to go out by twisting it. Do you do it or not? Huh? Do you do it or not?
Yes.
Huh? You remember,
Yeah.
like you are washing your towels, huh? So after that, what happens? So after washing it, you just twist it. Yes or no? One person holds it one end, other person holds it the other end, and you just twist it so that the water can be gone. Do you remember this thing? Hello,
Yes.
hello. So this is known as actually torsion. Is it clear now? What is torsion? Is it clear now? What is torsion?
Yes, sir.
Okay. So this is known as torsion. So now, what is ultimate strength? It is the maximum amount of strength that a material can withstand before failure. Suppose the stress that is being applied to a material just before breaking, that means the amount of stress that can't bear or resist just before breaking is known as ultimate strength. Now we'll discuss the next topic is elasticity. What is actually elasticity? Yesterday I asked someone, some of you gave the right answers also. So elasticity is the property of a material. Elasticity is the property of material by virtue of which we can gain the original position after removal of load. That is known as elasticity. Elasticity is a tensile property of a material, and the greatest amount of stress that a material can withstand without taking up some permanent set is called elastic limit. Now look, you all know you have seen a rubber band. If you pull it, it comes back to its original state, right? So that is the property of the material or elasticity. Now in elasticity, there is one limit called elastic limit. What does that elastic limit actually means? It means suppose you are applying load. huh? Suppose you are applying load. What happens after that? If you are applying load, then eventually that object or body will, after some time, stop coming back to its original position, and that load huh, or the stress that the material can withstand is known as the elastic limit. Okay, so this is elastic limit and or elasticity, and this is that strength. Hello, is it clear to everyone, students?
Yes, sir, it's clear.
Yes, sir.
Clear now? Okay. And if any one of you having any doubts, you just ask me regarding this Poisson's ratio, then bulk modulus, shear modulus, huh? Lateral strain, longitudinal strain, whatever. If you have any doubt, just ask me. No doubts? Ansari, did you understand your doubt?
Sir.
Okay, good.